And what we're going to do now is look at how you find the centre of mass from an area under a curve, and it's obviously two-dimensional. And the centre of mass for this shape, which is the function y equals f of x from A to B, and the centre of mass is called x bar, y bar. Can you imagine very roughly where it might be? It might be probably somewhere about here, I would guess. And in order to calculate the centre of mass, we have to use these two formulas. And the x coordinate of the centre of mass is 1 over a this integral, and the y coordinate is 1 over a times this integral, and a is the integral from a to b of that function. So we have a lot of work to do, I guess, is how you'd phrase it. So let's start with question 5. The function that we're going to deal with is a straight line. If it's sketched, it looks something like this. We're going to find the centre of mass of this object. So what I need to do is I need to reconstruct this guy. So I got my formula. I want my formula to be relatively simple to work with. So y equals is a good choice. Now going to this formula then, we now need to calculate a, which in this case, by the way, we're being asked to find the answer from x equals 0 to 3, as you can imagine from the picture. So it's going to be the integral of 0 to 3 of 6 take away 2x dx. Well, that's just 6x take away x squared, evaluated at 0 and at 3. So that's 6 lots of 3 take away 3 squared minus a whole lot of zeros, and 18 take away that gets me 9. So a little circle around that to remember that value is 9. Then find x bar. X bar is 1 over a, integral from a to b of x fx dx. So it's going to be 1/9 the integral from 0 to 3 of x times 6 minus 2x dx. Well, that's going to be 1/9 integral from 0 to 3. If you distribute the x, get that. You can do the power rule. 3x squared, take away 2/3 x cubed, evaluated at 0 and 3. Got 3 lots of 3 squared, take away 2/3 of 3 cubed, minus a whole load of zeros. That's 3, 9, that's 27. Take away 18. That's 1/9 of 9, which equals 1. So in this question, at least, x bar is 1. Let's find y bar. The y coordinate of the centre of mass in its formula is 1 over a again, the integral from a to b of 1/2 the function squared dx. So it's going to be 1 over 9 integral from 0 to 3 of 1/2 6 minus 2x squared. So it's going to be the integral from 0 to 3 of 1/2 36, take away 24x plus 4x dx. It's going to get me 18, 12, and 2. So power rule, power rule, power rule, evaluated at 0 and at 3. 18 times 3, take away 6 times 3 squared, plus 2/3 times 3 cubed, minus a load of zeros. 54. 54. 18. So y bar is 2, which means the centre of mass for that triangle happens to be at x equals 1 and y bar equals 2. So probably not where you would have thought it should be. It's about here. I don't know, maybe that is where you thought it would be. Definitely it's helpful that we have maths. It's definitely not obvious sometimes where the centre of mass of an object might or might not be. So let's do one last one. See what we can get. Let's do, let's see, which one shall we do? Let's do question 6. In this one, we are taking e to the x, nothing special about e to the x. We're going to do it from -1 to 1. And we're going to find its centre of mass. If you do a quick sketch of it, if you do the -1 here and you do one here, it kind of looks something like that. So that's the shape. Okay, let's get a, just the integral from a to b of the function. From -1 to 1 of e to the x. That's e to the x then, evaluated at -1 and at 1. And that gives me e to the 1, take away e to the -1. Not very pretty, that. So how about e take away 1 over e? That can become e squared minus 1 over e. And that can become e minus 1, e plus 1 over e. And that's just a prettier version of the same expression. So let's get x bar, which is 1 over a, integral from a to b of x, f of x, dx. Now, if you take 1 over this guy, you essentially turn him upside down. You use his reciprocal. So that's helpful. And it's from -1 to 1, and it's going to be x e to the x dx. I hope when you're looking at this, you're saying, I think I know that that's an integration by parts. So I'll make this f and I'll make this g. So it's going to be f capital G take away integral of f dashed capital G dx. Okay, you have an x, the integral of that is still e to the x. Take away a derivative of that is 1 times e to the x. So you're looking at that guy. So it's x e to the x, take away that, which is e to the x, evaluated at -1 and at 1. Okay, if you plug in 1, you get 1 times e to the 1, which is e to the 1. If you plug in 1, you get take away e to the 1. Minus, if you plug in -1, you get negative e to the -1. And if you take that guy, you get negative e to -1, which is quite worrying. But I'll continue. This guy is 0. This guy is -2e. You get +2e to -1. Oh, it's going to be nice. I thought it wasn't. But that guy's the same thing as 2 over e, which then cancel. And you're now left with x bar. So what we're going to do now is find y bar. 1 over a, integral from a to b, 1/2 f of x squared dx. Right, the a is going to be 1 over a, at least is going to be this fella. The integral from -1 to 1 of 1/2 e to the x squared. So it's 1/2 e to the 2x. If you integrate e to the 2x, you get e to the 2x times 1/2. That's why that is now a quarter. Going to evaluate it at -1 to +1. And you're going to get 1/4 e squared, take away 1/4 e to the -2. Okay, so I'm going to pull out the 4. That's 4 here. And I'm going to call that guy e squared. I'm going to call this guy 1 over e squared. I'm then going to combine those two fractions. Essentially what I'm doing is multiplying this guy by a special version of 1, e squared over e squared. If I do that, I get e to the 4, take away 1 over e squared. And then I notice that e to the 4, this guy, is actually e squared minus 1, e plus 1. Then I notice, even better, that it can simplify by factoring it just a little bit further. E plus 1, e minus 1. E squared plus 1. all over E squared. And then this one cancels this one cancels this one gets partially cancelled and leaves an E. And what you're left with is an E squared plus 1 over 4E. So the center of mass, which is that guy, ends up being 2 over E plus 1, E minus 1, comma, E squared plus 1 over 40. And that is us. We are now finished. Hopefully I'll be fighting fit tomorrow. I don't feel particularly good right now, but things like this change on a dime. So hopefully I will be good by tomorrow. Bye-bye.